Alright, I wanted to finish up 113. I ran out yesterday. So remember, as homework, y'all are supposed to come and make the towers. So you can see here that it just outputs uh, a lot of columns. It outputs 63 floors. You're supposed to make it into 3 columns of 21 floors. And you're supposed to have every 3 floors gray, then 3 floors blue, then 3 floors gray. So I indicated yesterday that what we can do. So let's say that we wanted, for example, 5 floors blue and 5 floors gray. Or 5 floors gray and then 5 floors blue. So what we can do is look at our number of floors. Since we want the pattern to repeat 5 floors gray, 5 floors blue, what we could do is do modulus 10, because we want that pattern to repeat. So if floor mod 10 is less than 5, I want the color to be gray. Else, I want the floor to be blue. If I stop and run this, note that there's an invalid syntax because I left off colon. Now we can see 5 rows are gray, then 5 are blue, 5 are gray, 5 are blue, 5 are gray. I can change this. So what this is doing is for the ones where if I mod the floor, 0, 1, 2, 3 remainders be colored gray, and remainders with 5, 6, 7, 8, 9 colored blue. And because this repeats every 10 floors, so what I'm doing, let me open up Paint and take a picture. What you need to be asking yourself is, what do you want to be repeating? Modulus enables us to repeat things. So what I'm wanting to do is repeat this pattern right here. I want it to repeat over and over again. I don't want it to repeat this gray, so I don't want to look at every 5. I want this thing to be repeated. So I want it to repeat here. So I use modulus 10 because I want to repeat this pattern. This pattern is 10 floors long. Or 10 rows tall. Your assignment is to make it every 3. So what would you change to make it every 3? Or I should say every 6. So you want this example uses 5 and 5 for a total of 10, and you're going to repeat it over and over again. So to make it ever 3 is gray, 3 is blue, this block would be 10 or 6. Sorry, I keep saying the wrong number. It'd be every 6. So if I wanted this to repeat, for example, ever 10 gray, so ever 10 is gray, and ever 10 other 10 is blue, I would do modulus 20. And if the mod or remainder is less than 10, so here you can see 10 are gray, 10 are blue, 10 are gray, 10 are blue, and so on. You don't have to do it like this. How I think they wanted you to do it is, let's just make it always gray. So now it's always going to be gray. But if for some reason the mod is greater than 10, we will change the color. Note this does the exact same thing. So as in activity 111, we pointed out that people program things differently. This does the exact same thing, but looks different. There are multiple ways of doing the same thing. Here, I'm going to give it a default color of gray, but every time the modulus is greater than or equal to 10, then I color it blue. So if I wanted to do, for example, mod 4, the only possible numbers mod 4 can give us is 0, 1, 2, 3. I want the 2 and the 3 to be blue. So if it's greater than or equal to 2, I'm going to change the color to blue. And if I run this, and I really hate the fact that this signs me out. Give me a second to load it back up. This is another reason why it would be more helpful to be doing this in Visual Studio, as Visual Studio doesn't require internet. And you don't have to worry about signing in every few minutes. It saved my sign in from yesterday, and then it expired, and I had to redo it. I think it gives you 24 hours, and currently I'm recording this at like 8:40 a.m. Oh, come on, hurry up. There we go. Just need to scroll up. Alright, so mod 4. So the first floor is 0, 1, 2, 3, 4, 5, 6, 7, so on. So if I do a mod on a floor number, this would be 0, 1, and this would be 2, 3 if I do mod 4. Then we'll repeat 0, 1, 2, 3, 0, 1, 2, 3, and I want 2 and 3 to be blue. So if the mod 4 is greater than or equal to 2, it's blue. I could have also done the default color is blue, but if the mod is less than 2, so if the mod is less than 2, I want to color it gray. And it does the exact same thing. So again, multiple different ways of doing the exact same thing. And I want to move this over. So suppose I want every 6th floor to be moved over to a new column. So notice how it starts right here. So we need to figure out where did this first place right here start. So let's look at the code. I give the starting location at -50 by -50. So this is 0, x is -50, y is -50, so I start it right here. Whenever I go up so many floors, I want it to go back up, or I want it to go right so much and then back down. So if I know that the starting location is -50, I want For example, the problem asks you to do it for every 21, but let's do it every 6, for example. What I do is if floor mod 6 equals 0, I want it to go back down. So again, these numbers will repeat. So if I do mod 6 on all the numbers, so this is floor 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on. If I do mod 6, the very bottom one, mod 6 is 0, then 1, 2, 3, 4, 5, and then once I do 6 mod 6, it'll repeat back to 0. So 0, 1, 2, 3, 4, 5, and then every 6th floor will be, when you mod 6, be 0. So at floor mod 6, whenever it's equal to 0, I'm going to take my painter and I'm going to reset my x values. So I'm going to take painter. Oh no, I'm not. I'm going to take x. I'm going to reset my x value. So x starts at -50, and I want it to move over. And if you notice here, I'm doing forward 50. So it's starting at -50 and it's drawing a line forward by 50. And I want it to so it goes to x comma y. I want it to come over to this point right here. So I'm going to increase my x by 50. And let's just run and see what it does. So here it says every 6 floors. Every 6 floors, it's the x value that it goes to is increased by 50. I also want my y to start back at my at the bottom. And remember that this spot right here was at here. So if I put in -50, you can see that now every 6 floors it goes back down. And again, you're supposed to make it do every 21 floors it goes over. And also alternate 3 gray, 3 blue, and so on. Anyway, I wanted to go over what I didn't go over in class. So decidable versus undecidable. It's a disappointing fact. We have proved that there are things in the universe that are unsolvable. This was a major discovery. It was a major proof that we figured out that there are questions in the universe that there are no answers to. Not everything is solvable. There are, so we learned this in math too, that there are theories out there in mathematical theories, in which you cannot come up with a mathematical equation to solve it. It's unfortunate. It was a very shocking result because we thought if we knew everything in the universe, if we improved our math skills, we would be able to solve any question. But it has been proved, and this is way outside the scope of a high school class, but we have proved that there are some things that are unsolvable. And that means that there are some algorithms that cannot be made. You cannot come up with an algorithm to solve a problem. So up until now, we have written algorithms to solve problems that are considered decidable. Decidable means that you come up with a yes or no question, and you figure out, is there an algorithm that can always tell you yes to that question or no to that question? And there are some problems that there's just no way of doing that. So they're considered decidable if they produce some predictable and correct output. There are some computational problems that are undecidable. So a decidable problem is a decision problem for which an algorithm can be written to produce correct output. For example, a decidable problem would be like, is this number even? We've already looked that you can do mod 2, and if the remainder is 0, it is even. So we can write an algorithm that checks to see if the number is even. There are some undecidable problems, is one in which no algorithm can be constructed that is always capable of providing a correct yes or no answer. So examine this program. Then suppose a user enters a number that is greater than 0. So here it gets a number. And then while that number is greater than 0, it adds 1 to it and checks to see if it's greater than 0. So if I come over here and put in -5, -5 is not greater than 0, so it doesn't execute this code and comes over here and prints this. If I instead enter +5, the program doesn't finish. It's stuck. It comes over here, is 5 greater than 0? Yes. Add 1, so 6. Is 6 greater than 0? Yes. So come over here, add 1. This program will never terminate. It can never decide, it can never exit out. And a very famous, is one of the first approved algorithms that are unsolvable. Asking, does this program terminate? There is no algorithm in which you can give a random program to. So you write a program, give it to this algorithm. There's no way you can make an algorithm that can determine whether that program will terminate or continue running forever. It's mathematically proven that there's no algorithm that exists that can determine whether something runs forever or stops. That is known as Turing's halting problem. It is very famous in computer science, as it's the first program that has been proved to be impossible to write. Humans are very good at looking at this. We can look at this very easy and say, no, if I give a number that is greater than 5, or even if I just wrote in this, if I do I'm greater than 0, do I equals 0, this program will never terminate. But there's no algorithm that I could write that could look at this code and be like, yes, it terminates, no, it doesn't. The only possible way is to have a human look at it and determine it. But there's no algorithm we can write. So that finishes up 1.1.3. They're supposed to answer these questions too. I hope that helps. So looking at 1.1.4. So 0 iteration conditions and infinite loops. In the last activity, you modified loops, mostly using less than and modulus operators to achieve different effects. In this activity, you gain more comfort with loops and learn how to troubleshoot situations in which loops don't seem to be behaving as expected. Either your loop never starts or never stops. You will use mathematical operators and the order of operations to modify the behavior of your code. This will give you more flexibility when you attempt to solve problems or create unique effects with loops in the future. See if scrolling actually causes this to fix. Alright. So let's look at this code. So this code, the value of the line. So this line starts at 5, and it checks in this while loop whether or not line is less than 5. When we run this, because line is equal to 5, it'll check here, is 5 less than 5? Answer is no, it's not less than 5, so it will never execute this code. This is called 0 iteration condition. Because it never enters this code, it executes this code, or I should say this code, 0 times. If I tried running it, we can see that it never executed this line. It never moved forward by 20. It never created a circle with a radius of 5. I think if you did this in Visual Studio, let me launch that real quick. It'll actually, Visual Studio is smart enough to detect this. It doesn't detect it always because, again, 0 iteration is a non-solvable problem. It's an undecidable problem. But sometimes there are some patterns we can use to identify. I think Visual Studio will actually detect that this is an error. But we're meant to run this. We're meant to run this section of code, but it doesn't go. So explain in your own conditions what this error is. It's an error in which the while loops code never runs because the condition is never met. Another way of testing this, by the way, let's test if this code if it actually enters here, and it's to add a random print statement. So print entered while loop. So if I run this code, we can see it never entered. And then I can put a print statement before, so before while loop, after while loop. It's very good to add print statements. So it goes before the while loop and never entered the while loop and immediately went to after, so it went from here to here. So if I were to copy this code and run it, see if Visual Studio will detect an error. So you can see it outputted a square and it went before. So this is an error in which Visual Studio and Trinket will not even be able to detect. So it's good to write print statements so you'll be able to tell. So modify this code so that it draws 5 circles. So this is the same thing. Let me add my print statements. So this is the code, so we can do before the loop. By the way, whenever you use print statements for debugging like this, before you submit your code, either comment them out or remove it so it doesn't print out. So again, whenever I run this, it never enters. So if I wanted to actually enter it, I need to fix this. This is the line we need to change. Now we can see it went before, it executed before the while loop, and it entered the while loop 1, 2, 3, 4, 5 times. So it ran and executed this line 5 times. And we can see that it drew 5 circles. Kind of hard to see, but we can see it drew 5 circles. So let's look at this code. Run the program and note your observations below. So when we run this code, what is going on? It's constantly drawing new circles. And it's continually doing that. It's never stopping. This is what we call implement loop. It does not wait for this program to do not wait for this program to end because it never will. So we set line equals 6, And this line, so 6, is 6 greater than 5? Yes, it is. So it comes down here, executes that, and then it adds 1 to line. So 1 plus line is currently 6. So 6 plus 1 is now 7. 7 sorted line, so now the line becomes 7. Then it changes the color based on these mod operations. And now line 7 is 7 greater than 5. Yes, so it comes down here, increments it by 1, making it 8. Is line greater than 5? 8 is greater than 5. So it continually runs over and over and over again. Here's another example of an infinite loop. So here I'm doing line equal 4, so it's 4 less than 5, yes. But now D increment, I reduce it by 1, so now line becomes 3. Is 3 less than 5? Yes. So I'll sit over here and just keep making it smaller and smaller, and we get the same error. It's an infinite loop. So here, create your own program that includes a 0 iteration loop and infinite. As your program, as you program your own little turtle behavior, you may find the reference of turtle methods helpful. So looking at, by the way, if you notice, I opened it up in a new link. I used the middle of my mouse wheel. Y'all on y'all's laptops don't have a mouse, but these are the turtle methods and explanations. You can just also right click on it and open in new tab. So I believe I haven't made up the write up for this yet, but I will add it. I believe I'm going to make y'all write this and provide your code. So for a 0 iteration loop, include a turtle maneuver that would never occur because the iteration were non-zero. So you could perhaps do while line doesn't equal 0, and you can have line equals 1, for example, and then you can have line equals line plus 1. Note that this will never be 0 because you're constantly adding to it. And let me check. Let's see. How far I was going to go today. I think this was supposed to be 4 days. Let me look at my calendar. Well, I'm waiting for that to load. The code word of the day is Charlie. So, arithmetic operators and order of operations. Do you recall learning about the order of operations in math class? The order of operations is important because if you calculate arithmetic operations, and arithmetic operations are mathematical processes that are part of most programming languages. They include addition, subtraction, multiplication, division, modulus operator too. in a math problem in the wrong, if you put a math problem in the wrong order, you'll get the wrong answer. Similar to mathematical operations, a computer follows the order of operations to execute a program, and you will use the order of operations to modify the behavior. Ackerman PEMDAS is often used to recall the order of operations. So we have parentheses first, then exponents, then multiplication and division, and addition and subtraction. So addition and subtraction are on the same order, multiplication and division are on the same order, exponents is by itself, and parentheses are top. The mod operator is included with multiplication and division. They're on the same order. There's also going to be additional ones. For example, function calls and our order will execute before returning everything inside of a function. Once it reads that, we'll go into that more detail later. So in the event of a tie between multiplication and division, or addition and subtraction, operations are performed left to right. So we have a multiplication and a division and a multiplication. They're all in the same order. Mod is also included in this order. It execute left to right. So first we'll do 6 times 10, that's 60. Then 60 divided by 5. Next, do left to right. And then 12 times 2, we get 24. The mod operator has the same precedence as multiplication and division operators. Division is represented by a slash. So these are all the same order. So we will do it left to right. 6 times 10, 60. 60 divided by 5, 12. 12 mod 3 is 0. 0 times 2 is 0. Python has some operators of its own. The dot operator gets the function of a method. So it gets the method of a class. So this dot operator is actually higher than parentheses. So when it looks at this code, we see a dot operator and we see parentheses with 5 in it. What it's going to do is get this function first. Then it's going to look at the parentheses next, execute the parentheses, and then pass it into the function. I think I worded that slightly wrong. Take that back. It will execute the parentheses first. Anything inside the parentheses. Then it'll execute the dot operator. That's the correct order. So it'll execute anything in the parentheses. Then it'll combine this into a single function or method call and pass whatever is inside the parentheses to it. It is considered after the parentheses and before any mathematical operator. So yes, so it'll execute after the parentheses are executed, but before any mathematical operator. So if I had done, for example, I'll just use Google as my thing. So if I did this plus this, it will execute. It'll take the 5. So if I do 5 plus 7, it would execute this first. So it'll execute 7. Then it'll execute this. Then before it executes the plus, I had this minus 2. So the order of operations is this. It'll execute this first, return it to the parentheses, then it'll combine this into a single statement and pass the 7 into this. It will, because plus is less than dot operator and parentheses, it will execute this next, then pass it to the painter.write argument, so it passed 3 into that, and then it will execute both of these. Note this is kind of wrong because you can't add these two values together, but I'm trying to use it as an example. So examine the two programs below, each using a arithmetic operator and the same number And the same numbers to move a turtle. So if I run it to test, we can see that move to the left. So what it's going to do is come down here. So what it's going to do is go look at this dot operator, and it's going to look at the parentheses. It's going to execute the parentheses first. Parentheses take a higher order. So whenever you do a function call, it's going to execute whatever inside that method or function. So it's going to execute this first, pass it to this. So it'll do 4 minus 5. Then it'll come over here plus this, and it'll execute this, the innermost parentheses first. So 18 divided by 4, and then I'll come over here and subtract it to 2. Then it'll take, because this is now multiplication, it'll do 7 times this. So that is negative 2.5. So do 7 times negative 2.5 times 2. And then it'd be negative 1 plus negative, wherever this result was. If I change the order of operations, so if I put parentheses instead around this, we note that it does something different. It now moved it over to the right. Because this line of code, so execute that inside first. So that, I can do my, is 104. So it moved over to 104. And that up there had executed to negative 36. So use your knowledge of mathematical operators to write the following algorithm. Ask the user for 2 numbers. Determine if the first number is evenly divisible by the second. Recall that not equals compares inequality. So this is called the not operator, by the way, NOT. So we say this exclamation mark, we call that not. That in computer language is called not. And so exclamation mark equals is called the not equal sign. And you can see Google is actually already predicting it. This is called not equal to operator, and this would be not operator. That's called the not operator. This would be called the not equal to. So this was what I was going to have y'all do Wednesday, is to work on this. So doing number 6. And that's where I'm going to stop today. We'll continue back up on Monday. I'd like y'all to do this. And this is primary what we're supposed to be doing for Wednesday. So determine if the first number is evenly divisible by second. Repeat steps A and B until the numbers are evenly divisible. So use your knowledge of mathematical operators to write the following algorithm. You take in 2 numbers. Remember, whenever you ask for input, you're going to need to cast this by using int. So remember, you're going to get like number. You do input first number, and you're going to need to store that to a variable. But before we store it to a variable, we need to put int around it and store it to some variable. Rename this, and this will get your first number and store it to that name of the variable. Determine if the first number is evenly divisible by the second. So what does it mean to be evenly divisible? Well, that means that we, when we do mod, if something is evenly divisible, for example, 6 divided by 2, that's evenly divisible, that's 3. So the remainder, so it's equal to 3 remainder 0. 7 is not evenly divisible. 7 divided by 2 is 3.5. So if it's not divisible by the second number, its remainder will not be equal to 0. Determine if the first, this is something, because you need to repeat steps A and B until the number. Give me a second, I will look that up on my teacher side. I think that what that's asking is for you to divide it and get the to actually divide and loop. By the way, this can be executed without using any turtles. You don't have to do turtles. You don't have to import turtle module or do the main loop at the bottom. So yeah, what's this supposed to be doing? I just looked at the solution. Let me look at it again. So what you're supposed to be doing is you get two numbers and you check to see if they are divisible. If this number, so this variable 2, divides into this one, you would check to see that by, you could do while this variable mod this variable is not equal to 0. So while it's not equal to 0, get two more results, two more numbers, and keep repeating this until the user inputs two numbers such that the second number divides into the first evenly. So repeat steps A and B until this works. And then you can, so you should first, I should say, you should put after the gather the user input. So you need to print, for example, print number A, our first number, wherever your first number was, divided by wherever your next number is, does not divide evenly. So inform the user of the result. I'm just doing this very lazily. you should actually make this more neater. And if not, you come over here and print get 2 more numbers, and you keep repeating this until it's until the user inputs. So for example, no. And this should be second. And I put the extra comma. And then you'd put does. So very lazily writing this. First number 5, second number 10. First number, or wherever, reword it. I'm horribly writing the words. 5 divided by 5. That's because this should have been 2. So 5, 2. 5 divided by 2 does not divide evenly, or you put 2 does not divide evenly into 5. But if I do 10, 5, this number divides. And again, I've written this horribly. You should be writing it better than me. That's all you're supposed to be doing for tomorrow. And that's it for the day.